is the distance program, or is a lot way in the class program, right?
I'll take a look and see if I got the dates off, and then fix them. The dates in the Blackboard don't line up with these.
Because one of their modules, and I was wondering because you mentioned that we're trying to change this program to use classes, correct?
Yes.
So I know there's also a class program after that, unless that's.
Yeah, I'll go and check. Also, I think the label in the actual in the Word document is a little off. So I'll take a look and get them all lined up. So let's see. Okay, so give it a second here. Okay, so exceptions. So up to now, when we've had errors, what do we get? We get like that big red ugly message that says unhandled exception, yeah, syntax error. Do we really want our users to see that? No. The answer would be no. We don't really want to see them trace back, most recent call last, file standard in. That will make them get really anxious and run out of the building screaming. So we generally don't want that. But these error messages have helped us out because they give us the line number where the error is, and then they tell us what the problem is. So normally we want to see those errors when we're writing code, but then at some point we want to handle those exceptions, and this is what exception handling is about. So, and what an exception is, it's actually a class. So we saw how you can write a class, and you can actually, I don't think we looked at an inheritance. No, we did look at inheritance, right? Last time we saw how you could, in parentheses next to the class name, we can inherit from, yeah, we can inherit from another class. So there's an exception class, which is the top level exception, and then there's a whole bunch of other classes that inherit from the base exception class to get more specific. Oh, thank you. Let's see, share application screen. So can you all see the video? Great. So, so this is what an exception normally looks like. You know, trace back, most recent call last, and that's what we don't want to see the user to see. And an exception is basically a class. And when you have a problem happens, an instance of this exception is created, and it's kind of surfaced by the program in the background, and it carries all the information associated with the problem that occurred. You can actually raise your own exception using the raise statement. So give this a try. in idle, write raise and then just the word exception with a capital E. And tell me what you get. Do you get traceback, most recent call last, file, PyShell, number 0, line 1 in module, raise exception, exception? Does everyone get that online? Yeah. So how do we read that? So this part right here is the call stack. In this case, we raised it at the we raised it up here at the command line. So when it says PyShell number 0, let's see if I can get a thinner. We say PyShell number 0 there. That basically is the shell. So if it was your program, you would see your program name there. And then it gives you line 1. Well, in the shell, we only have one line, so that's why it's line 1. And then we don't really have a modular running in, so it kind of gives you these things. And it just says, and then it gives you the line of code. So so right here, it says that's the line of code that we wrote, which is up here. Does that make sense? So try this one. Raise exception, hyperdrive overload, in quotes. What do you get? Does everyone get a hyperdrive overload? Does anyone believe that Python has created a hyperdrive handling function? No. Basically, what this shows us is that we can create an exception and tell it what we want the message to be. But we still get hyperdrive overload error that shows up. And so that's how we can when we raise an exception, we can create whatever error we want. Now, most of the time, we're not actually raising exceptions ourselves. The Python itself will actually raise the exceptions when we have errors. So if we do a divide by 0, the functions that actually do the division will recognize that the lower the denominator is a 0 and will actually automatically surface an exception for us. And if you go look at the documentation, they'll show you all the different exceptions. Some common ones that we use are these. The exception, the top level exception one, which we already used, is just the top level exception class. It will catch any problem that happens. But we can also have attribute errors. So if we have a problem with an assignment operation, I/O error, when we're dealing with files later on, you can actually catch I/O errors, which might indicate maybe that a file didn't exist that you're trying to open or that you couldn't write. You might also have index errors if you tried to index, say, a list beyond the number of items there are. So if you had 4 items in the list and you tried to get the index of item 5, it would give a index error. Name error, key error, if you're dealing with a dictionary. Name error, let's say you try to reference a variable that doesn't actually exist, you can catch that one. Syntax error is when it's ill-formed. Usually you don't even get the program to run with syntax errors. Type error, if you maybe tried to do math with a string in a way that it can't do, like you could do addition, it would do concatenation. That's one of the things about Python is actually you tend to not get as many errors in other programs, because the great thing about Python is it does everything you tell it. It figures out a way to do anything you tell it to do. The truly horrifying thing about Python, of course, is that it generally makes your code run and does whatever you tell it to do, and it may not be something you wanted it to do. Hence, you get hyperdrive errors. Hi. Come on in. The other thing you can get are value errors. So you might have the correct type, but an inappropriate value, or zero division errors, which are probably going to be one of the more common errors, is where you try to divide by 0. So those are built-in exceptions. They're defined. Those classes are defined by Python, and they will generally be raised by some Python function. And you've seen them because of errors that you've had when you're debugging. You can actually make your own custom exceptions. These would be used often when you're making a class. Maybe there's an input that you wouldn't want them to do, and so you might make your own exceptions that you might raise. So inside of a set method, you might check to see the value they're setting. If they set something that's incorrect, you might want to create your own exception. So we're going to create so if you want to create a hyperdrive exception, you could do something like this: class some custom exception, and note that that we have this here. What is happening with the area that I just highlighted? What happens when you have a class and you put a name of another class in parentheses? Anyone online know? Yes, this is inheritance. So we're saying some custom exception is going to inherit from exception. So all the behaviors of exception will be available to some custom exception. And notice that we put this keyword pass. What does pass do? Yeah, actually pass in Python is just a keyword saying, I don't want you to do anything here. But because we have a colon, because we have this colon here, it expects something. So we have to at least type pass. So when we make a custom exception class, we don't actually have to write any code for it to do anything. We're really just saying make this class called some custom exception and inherit from the exception class. So make one just like exception, but call it some custom exception. So we're just making a duplicate of the exception class, but we're giving it a different name. Yeah, like when we did the multiple inheritance example, we put pass in there because it was getting all its behaviors from the parent objects. And so we didn't really need to add anything else. So we used a pass. So I think it gets used a lot when we use inheritance for that reason. Sometimes people will use pass temporarily in a function, like they want to stub out a function, they want to be able to call it, but they don't want to write the behavior right away. So they just pass in there temporarily, and then they'll fix it later. So that's how we'd write a custom exception. We're not going to have you do custom exceptions, but if you come from another programming language, you might have been used to using that, and it is powerful to be able to write your own exceptions. What we're going to primarily use exceptions for is to try to catch them. So you have an error, you have certain inputs that the user puts in, and then it creates a problem with the program, and we want to be able to catch it to tell the user, hey, that's not going to work. So let's do this. Let's make a program. X equals float input, enter first number. Y equals float input, enter second number, and then print X divided by Y. What kind of error do you think we could get from this?
Yeah, parsing error, something like that, saying you can't.
What could happen there? Yeah, so is that going to get a, so we will get, we have numbers, but we have X divided by Y.
So it's going to, it'll divide the values.
Right. What if the user puts in 0 for Y? We'll get a divide by 0 error, right? So go ahead and put that program in and run it. And then put in 10 and 0 and see what we get. Yeah, you should get a 0 division error. Does everyone get a 0 division error? Yeah, so, okay, so that's not ideal. And can we keep the user from typing 0 into that code? Is there a practical way for us to write code to keep them from typing 0 in there? Probably not. You might be able to do some kind of if check or something before you do the division. So that would be possible. And so you could do validation, right? We could run an if statement in front of it, say if y equals 0, display an error message, and then we loop them around and give them another chance. But another way we can do this is with catching exceptions. So right now, this error message is not a good user experience. Anyone know what user experience is? It's this term that they use for user interface design. And basically, it's exactly what it is. It's what kind of experience is the user having? Is it good or is it bad? Anyone ever use an application which has way too many buttons on it? That's not a good user experience, right? It's confusing. You have a hard time figuring out what's going on. So a lot of user experience is interface design. Part of it, though, here we're not dealing with the GUI. We're dealing with a console application. But is just how the program flows. In this case, this kind of error actually, not only does it look ugly, it's hard to read, but it stops the program, right? They can't go back and try again. So we don't like that. So what we're going to do is we're going to fix it by doing a try except. So we're going to create a try block. And we're going to put our suspicious code in the try block. And then we're going to have an except block. In this case, the except block is going to catch a 0 division error and is going to display a much nicer error to the user. And so if we're picking code that's going to be suspicious, what would be the primary thing that we'd be considering as code that we should be suspicious of? Anything the user puts in, right? So as a programmer, you learn to recognize that the user is the source of all problems. And so we know that if they put in a bad value for y, it could mess up our code. We're not only putting in their user input, x and y, but we're also putting in, notice, we're putting in this code right here, print x divided by y, because it's dependent on the inputs they put in. And it might mess up because of what they're putting in. So go ahead and write this program, and then and then run it and put in the first number 10 and second number 0 and see what you get.
Those, the zero division out.
Yeah, so you notice we got a better message. That work? So we get a much better error message to the user. This is a better user experience. It does that work for everybody online? So let's try this one. Make a new program, say num string is equal input, please enter a number. Num is equal to float of num string, print the square is num raised to the second power. And then run that, oh, and then, what's that?
It's not working for me either.
Oh.
So there's unsupported offer and types for the function of it. This is to be like this.
Should just be one parentheses. You have an or right there. That type needs to be deleted.
Oh, okay.
Make it
Oh,
actual.
that's your
That was my cursor, yes.
cursor.
Oh, okay, I see.
Okay.
Yep, and then run it with 0.
With 0, okay.
Yeah, run it. And then you see the exception caught it and displayed your message. So you can customize that message then.
Oh, okay.
So now try this one. Num string is equal to, we're going to input a string, then we're going to convert it into a float, and then we're going to print the square of that number and try it with FIVE. Ryan, so accept is not working. Look at the spelling of accept. What is the error that it displays to you? Check your tabbing, see if it's tabbed correctly. And if you can, copy that section of code into the comment.
So could the except be also used in like a, to substitute for like else, so. Hold on. Like for example, for a rock, paper, scissors game, and if you had put in anything other than rock, paper, scissors, and you make that, you could do an exception, so that way it would block out. Because instead of putting it as an else, you can also put it as an exception.
Yeah, if you were like maybe doing the index function into the list to see if it was in there, and it shows those exceptions, you could catch it that way.
Okay.
Yeah, so that would give you,
Based off my list.
yes,
Okay.
yeah. If you were like, if you did something that drove that error to happen,
Okay.
then you could use that as a way of validating if they had the right input. I'm not actually typing anything in there right now, Sawyer. Let's see. So let's see, we have except zero division error. I think your code should work, Ryan. I would probably have to look at it in more detail. So send me your Python program if it doesn't work later, and then I'll try to get it fixed. So FIVE, it can't convert FIVE to a float because it's the letters FIVE. So we get that error. And so what error do we need to catch with this example?
Make sure it's capturing the square.
Well, we can actually, so this is the cool thing is, when you run your program, it will actually tell you the name of the error that you need to catch right there. So what I recommend doing in order to good catch, Brendan. If you don't have a try, then you probably can't catch the exception. So try putting the try back in there, and it'll probably work. So so when you write your program, what I recommend is don't put the exceptions in initially. Write your code, make it work, and then try to make as many errors as possible. Put all kinds of weird inputs in, hit enter when they ask for a value, put a string in when they ask for a number, put a number in when they ask for a string, put really large numbers, really small numbers, and try to drive the exception messages to come up. And when they do, keep track of what error. This one says value error. And so they will always tell you this is actually the name of the error class that you need to catch. So once you have that, you can then now write your code. So now change that code so we have a try except, and we're going to catch the value error. Cool, nicely done. You all found the error. So rewrite your program here so that you catch the value error. And we're going to print the somewhat accusatory statement, that was not a number.
So you can just tell it value error, and it's just gonna populate that and not accept that error.
Right. So if a value error happens, it's going to say that was not a number. If any other type of error happens, it won't do anything. But we're going to learn later on, you can put as many except blocks as you want. So you can have a separate except block for every type of error you want to catch. So is that working for everyone? And then once you have that, go ahead and type in FIVE, and you should get, that was not a number. So that's kind of your workflow, right? Your program, make errors happen. Keep track of which errors are there, and then write an except block to catch those errors. Does that make sense? So the workflow is basically write some code, test it, try to find inputs that cause exceptions, note the exceptions it causes, wrap the code in a try block, add an except block with your own error message. I also recommend you do this at the very end, because those error messages that we write, they don't tell us what line of code the problem is on, right? So we want the error messages while we're debugging and fixing our code, but once we're done, then the last thing you do is wrap it in except blocks and try blocks and then catch the exceptions. So some common exceptions that we catch are the arithmetic error. Note that just like all the exceptions fall underneath the overall exception, overflow error and zero division error are subsets of the arithmetic error. So you can catch arithmetic error, or you can catch something more specific like zero division error and overflow error. The overflow error happens when you try to put a number that's too large in. Thing is, Python automatically converts your types over. So it's actually really hard to put in a number that's too large for it. If you hold down the 9 key and just let it, make a big number, and then copy and paste that over multiple times, you can make a giant error. But that's the thing about Python, is it actually does a lot to keep errors from happening. And then IO error, index error, syntax error, tab error, and type error are often frequent ones that are caught. So that's what we have for today. It was just looking over the exceptions. Next time we'll go into exceptions in a little bit more detail. We'll see how to raise multiple exceptions, or how to catch multiple exceptions, and some other elements. So are there any questions on exceptions? Whatever's on the schedule, yes. And the rest of today is going to be lab time. So if you need some help on your programs, if you're online, I can make you a presenter and you can show me your code, or you can, probably the easiest is for you just to email me your code, and then I'll review it and give you answers. And then if you're in the room, I can look at your code. So any other questions online? So int object is not callable. Most likely what that means is you missed it's going to be right about here. And the reason it does that is that 2, it thinks, because you put a 2 in a parentheses, it thinks you're trying to call the 2 like a function. So you really need an asterisk in there. So that needs to be that's what's missing. Does that make sense? And some of you may have seen, I think it's, a number of people have that, and it's because we're used to how math works normally. We can put numbers in extra parentheses, that means multiplication. In the computer, though, the way Python works is it whenever it sees parentheses, it thinks, and there's anything in front of it, it thinks that you're trying to do a function call.
Right, okay. Interesting. So would a comma work in that case, or no?
No, if you put a comma, then it thinks you're trying to make a tuple. And so it'll evaluate the first half of it as one thing, and the second half of it is another. And then I think also in this function you have an atan. So in math we say atan2. Oh, actually, I think what you wanted is, you want the atan2 function. So it really should be this, 2 times atan2. And then you have because the A10-2 takes two parameters, comma, square root, etc. So it should actually be like that. The 2 is part of the name of the A10-2 function. So it uses the A10-2 function, which takes two parameters.
So I get it to finally work. But to the point where so it's not catching my errors. So if I put in 20, so I will give me the distance, which is what I need, and then put in my y. And it'll say invalid as a track.
So let's take a look at your,
And then it just continues. So I'm wondering if I think my positioning is wrong. I have.
So it's over here. So question, that, these print statements part of the else, or are they part of the while?
And my continue should be fine.
No, go ahead and put the map. Tab them in.
Oh, okay.
No, tab them that way.
Oh, okay.
So they're part of your else.
Oh, okay, I get it. Okay.
And then what I would do is put in a character term after the doing. So you don't really need this, because if it's not that, it's going to be this one. And the else, and you don't need to continue because it's going to automatically continue anyway.
Okay.
So you can get rid of that.
So
you don't need this logical expression because this one's already doing that.
I don't need my else.
No, you leave the valid answer. Well, and actually, really, you probably could get rid of this whole if statement because it's going to be evaluating up here anyway.
Right.
So you could probably just get rid of all that if. Get the input and come back around and do the evaluation there.
I've done this over 4 times.
No, it's not unusual.
3 times. I redone it and redone it and then first, and so after I got through everything, it was this, I wasn't putting properly at the right point.
Yes.
So I emailed you one last night and I redid it again today and I was like, that's it. All I do is dream of this stuff and I couldn't wake up, I woke up and I redid it.
That is actually programming. We're not used to that. We're not used to we try something that fails, try something that fails, try something that fails, then having to go back and rework it.
But that is the nature of programming.
Because I thought something that my thinking in this was that I needed to unpackage my definition for distance when I was talking about first point, second point.
Yes.
And so I unraveled everything and thought it needed to go that way, but technically it was just this piece that I needed was just putting the longitude, latitude, 1 and 1 and 2 and 2 equals, you know, point
Yes,
for 2.
to unpack it into-
In my define function.
Yeah.
Okay. Think I got this.
Yeah, and you know, that's,
Yeah.
when I write code, that's what I'm doing all day. I'm writing something that's not working, I'm figuring it out, and then I may work, you know, I finally get it to work, and then I look at it, and it's like, you know, this is a little convoluted, and then I try to refactor and get it. It's a constant work and rework to make it better and better and better. So it's just the nature of programming. Let's see, you got a bigger number because the radius of the Earth. Yes, you do need to make sure that the radius of the Earth is the same in the units.
Yeah, it's better to try. No, it should be 101 point something miles, not 2,500 miles.
Oh, well. Yes. And so when you get to your inputs in, you probably at some point have a lat1 long one, lat2 long two. Recognize that you're going to ask the user for the inputs in decimal degrees, but then you have to convert to radians. And so there is a math.radians function. So if you pass in degrees to the math.radians function, it returns the degrees into radians. The other thing, you can always multiply by degrees times pi over 180. We'll convert into radians.
So, like I said, if the user enters their input as, or tell the user to enter their input as decimal degrees, you don't have to do the conversion, right?
You do, because the math functions in this, the sine, cosine, and tangent and atangents are expecting to get their parameters in radians. So you got to take their decimal degrees and convert them into radians. And usually, as a matter of course, what you should get used to when you're working with math in computer programming, just have some, you know, probably, you know, you may ask for the user for their inputs in degrees, but then store it in radians, because it'll just make it faster to do your calculations. And then when you display it, you could convert your radians back into degrees. You know, I recommend storing your distances in meters, because it's easier to do, you know, meters to kilometers and those types of calculations. And so you always store your stuff in kind of one, you know, don't store like your data like feet in one place and meters in another place and something else in another place. Keep one consistent unit for distance, one consistent unit for degrees, one consistent unit for weight. And, you know, either everything gets stored in metric or everything gets stored in English measurements, but you stay with one within your program so that you don't have problems. And then you just convert back and forth when you display information and pull information in. It'll avoid your satellites falling out of the sky or rockets exploding upon launch. Sure.
So the first one, I just your tabs, there's no tabs, or it's class construction and C++. So I was wondering, is this what you want for task description? So I have comments
I would expect to have like a Word document where you talk about the concept, then you refer to the pieces of code. And what I would recommend is actually what's easy is, you have call outs in Word so you can point to things and refer to them. So you don't necessarily have to put them in comments into your code.
Okay.
And it'll keep your code a little bit more concise and a little easier to just put pointers in. But I do need a little bit more explanation of what's going on. So in this case, we're talking about
Just the,
instantiation and definition, right?
yeah, the first part was just showing what a class was.
Yes. So, you here you would say, class is basically, you talk about what a class is. And then in here, then you might point to things and say, this is where the constructor is. Then you talk about what a constructor does. And then, notice that, starts with class keyword, and then we give end private. And then, we have a private section, a public section, and we go on like that. Does that make sense?
Yeah. It's pretty much this.
Yeah, and that, I need more explanation. And what you're trying to do is convince you want to write it to the level that it convinces an employer that, yes, you understand this concept. If they just see like a little comment, just a one line, it may not communicate enough, so we need at least, a short paragraph, just enough to kind of explain the concept. Okay, thanks.
And then, so our convert radians, because I am missing that. It can go under my distance function.
Yeah, you could,
Let me just pile it in here.
right after you got latitude, you could say latitude 1 is equal to math.radians latitude. Yep. So you're just taking its value, and then you convert your radians and start it back in the same variable. Does that make sense? And then you would do the thing for all of them. Let's see, a question online. Yes, decimal degrees need to be converted to radians because if you look at the sine, cosine, and tangent functions in the documentation for the math library, they take radians as the parameters. And probably the easiest way to do that is at the very top, you may be getting 0.1, 0.2, you could do something like this. Something like that. So then the rest of your function would be dealing with radians. And there's a lot of different ways you could do it. You could even put math.radians within every little thing that you did, but that would be painful. So you could just convert it right at the top.
And if you did do it in each radians, wouldn't that go against the dry?
Yes.
Try to reduce.
Yes, exactly. The cleaner you make, the less you have the same thing over the place,
the easier it is to fix things later on. So yeah, I would probably like to just, I'd probably bring it in as radians at the top, and then my formula would just be nice and clean and easy to see. And the other thing too is, the more sometimes we can use our variables to kind of roll things up, and the way you do that can make your code easier to read. It's A10-2. Put a 2 after A10, because it's the A10-2 function, not the A10 function.
So for the classes, just explain what the program is doing and how a class is constructed.
What's that?
Sorry. So for the classes, just explain what the class is doing and just
Yeah, explain
or what the program is doing per se and what exactly is a class.
Yes.
Okay.
So imagine I'm an employer and you're convincing me that you know what a class is. So I would ask you, what's a class?
Okay.
And so, well, a class is, if you want to say it's a template or it's a blueprint or it's something like this. And the way we define one is we use the keyword class, we give it an identifier, and then we have a block of code, which is a collection of functions and variable declarations.
Okay.
And that variable declaration, maybe you could go into, we call attributes or field. The functions we call methods. And then, you would go through and just kind of point things out in the code, or you can take snippets of code and put them between your explanations.
Okay.
Right?
Okay.
Does that make sense?
Yeah.
And part of the reason to do this is so that if someone said, if you were in a job interview, we said, tell me what a class is, you're just going to go right off into it because you've had time to articulate that. What constructor? Oh, constructor is how we initialize the values for a class. It looks like a method definition, however, it has the same name as the class. And when we call it, it instantiates a place in memory and structures it to store all the variables and the fields and attributes for our object. Things like that.
Okay. That works.
Cool. Thank you.
I don't think I have it correct.
Math, you might need to say math.a10-2 or make sure that you've imported a10-2 from math, import a10-2. So you make sure you're importing it. Or you need to put the math dot in front of a10-2.
Close. So it would be math.reading's first point, right?
Yes.
And then it would be index 0.
Well, in this case, then, if you did that,
0, 1, 0, 1.
yeah, and then you don't need these 2 lines anymore because you're doing it.
These 2?
Yeah, because you're doing it with these other. So yeah, you're taking the radians of, you're taking the first point, index 0, turning the radians to that lat 1. First point, index 1
1.
for
Okay.
longitude.
Because it's 0 and 1 for each first point, 0 and 1, second point, 0.
Yeah, because they're a tuple with 2 elements. Yes, you got it.
I just think that's the things, putting it back in.
Is that pretty close? Doesn't have to be super precise.
It is pretty close. It says, so within miles, it's 64.1. in kilometers is,
There's actually conversion functions in online. You just go convert, go open up a new browser and say convert miles to kilometers. No, just type the convert function, because we just want a calculator. So hit that. And then right there, you can put in your miles. Or whatever, let's see, that's kilometers, right? Yeah, so put in your kilometers there. Yep, and it says, it's kind of approximately like 58 miles, and then look at what you have in your maps.
yes, it's about 64, but it depends on what.
Yeah, so it's close enough.
Okay. Yay, okay, so so I don't need to code it to translate it into miles.
I don't think I specified that, I just said distance, yes.
Okay.
Just make sure that when you output it, that you tell what units it is, and then it works.
Thank you. Feel better.
Yes, so if you're getting a really large error, it could be maybe you're not taking a square root somewhere that you're supposed to. There could be so that's a pretty large order of magnitude. It sounds like it's like there's somewhere where you should be taking a square root that's not, or you can do your maybe somewhere you didn't convert something to radians. Sometimes what I've seen people do is they will subtract out, like the lats before they do the radian conversions, and then it kind of messes it up. So you've got to really look at your formula and walk through to make sure that you're calculating it properly.